Like the Antarctic ice sheet, the Greenland ice sheet is a dynamic polar region where the atmosphere, temperature, and ocean currents force changes to the balance of the ice sheet.
In the Arctic, we have a wide variety of glaciers and ice caps, but the largest glacier is the Greenland ice sheet, and it's composed of a number of different outlet glaciers and land-terminating glaciers. When an ice sheet is in balance, the amount of snow coming in is equal to the amount of melt and calving that is going out. In Greenland, unlike Antarctica, we have a situation where we have large amounts of melt and large amounts of calving, so that Greenland is losing mass regularly every melt season. And the accumulation during the winter does not balance that mass loss that occurs during the summer. Atmospheric currents play a really important role in directing warm bodies of air onto the ice sheet. And as the jet stream moves from the west across the Greenland ice sheet, it can add a substantial amount of moisture and warmth to the surface of the ice sheet and cause increased or elevated surface melting. Surface water on the Greenland ice sheet only flows a small distance on the surface. It eventually will reach a crevasse or a moulin, which is this large vertical conduit that is named after the windmill in French, and that is because it makes this large whooshing sound whenever water goes in. They act to drain large volumes of water, almost all of the surface melt that occurs on the ice sheet, to the bed of the ice sheet.
The ocean surrounding Greenland also impacts the changes to the ice sheet.
Warm ocean currents from the south travel along the edges of the Greenland ice sheet. And as it travels along the edge of the ice sheet, this water can intrude into these fjords along the periphery. And this intrusion of warm water can then interact with the front of outlet glaciers, which can increase the amount of melting, it can speed the rate of calving, and can substantially influence the dynamics of outlet glaciers. This imbalance in the ice sheet is continuing to grow. This increase in melt intensity and extent alters the surface reflectance of the ice sheet, which we call surface albedo.
The ice sheet's albedo helps cool the planet by reflecting solar energy back into space. The ICESat-2 satellite will measure the changes in thickness of the ice sheets, which will help us understand how changes in the reflective nature of the polar regions could affect climate.